Hello and welcome to this video where we will discuss some problems regarding the topic solid mensuration. We are the fifth group of MECC 481P1C2. Next slide, please. First problem is to find the volume of the solid shown below. Next slide, please. The figure is known as a cone frustum, and its formula for finding its volume is pi h over 3 times the quantity large R squared plus large R squared times the small r plus small r squared, wherein the large R represents the radius of the lower base while the small r represents the radius of the upper base. In the figure, 13 feet is not the height, but rather is the slanting length. So we still have to solve for its height. Looking at the figure, we can see that the relationship between the diameters of the two bases is that the lower base is equal to the upper base plus 2a, and a can be solved to get 5 feet. We now have two sides of a right triangle where 5 feet is one side while 13 feet is the hypotenuse. Using the Pythagorean theorem, we can solve for the height as 12 feet. And substituting for the values to the volume formula, we get the answer of 3,480.8847 feet cubed. Next slide, please. Problem number 2 asks what is the volume of the spherical wedge with radius 85 meters and dihedral angle of wedge 45 degrees. Next slide, please. In this problem, we can use the formula V is equals to pi r cubed theta over 270 degrees, wherein theta is in degrees. Substituting the values, we get the volume of the wedge, which is 321,555.0981 meters cubed. Next slide, please. Problem number 3 asks us to find the radius of the circle below. Next slide, please. The circle having the sides of 5, 12, and 13 units. For this, we can use the formula for the triangle circumscribed in the circle. AT is equals to ABC over 4R. And rearranging, we got the formula radius is equals to ABC over 4 times the area of the triangle. To get the area of the triangle, we can use the Heron's formula since we have the lengths of the three sides. First, finding the semi-perimeter, which is 15, and then finding the area of the triangle to be 30 units. Substituting this to the first equation, we can get the radius of the circle to be 6.5 units. In this problem, there is also another way to solve it. According to Thales' theorem, if 3 points A, B, and C are present in a circle forming a triangle where one line passes through the circle, then one angle is a right angle. Inversely, we can also say that if a right triangle is circumscribed in a circle, that means that its hypotenuse is the diameter of this circle. We can prove that a triangle is a right triangle by using the Pythagorean theorem and substituting the values. Here we can see that the triangle is indeed a right triangle and 13 is its diameter. Then we can get the radius of the circle, which is half of its equals to 6.5 units. Problem number 4 states that a dog is tied to one of the corners of a rectangular building using a chain that is 40 feet long. The dimensions of the building are 30 feet by 20 feet. If the dog can reach wherever its rope allows to reach, what is the maximum area the dog can cover? Visualizing the problem is the figure on the right. The shape consists of 3/4 of a large circle with radius 40 feet, 1/4 of a smaller circle with radius 20 feet, and another 1/4 of the smallest circle with radius 10 feet. Finding their respective areas and adding them, we can get the area of 4,162.6103 feet squared.
For problem number 5, the problem is the arc length is intercepted by a central the arc length intercepted by a central angle is 3.5 inches. The radius of the circle is 1.5 inches. Find the area of the segment intercepted. So in this problem, in order to further visualize the problem, the figure in the right is constructed. In order to find the area, we use the formula 1/2 r squared multiplied by theta minus sine theta. In this case, we already have the value of r, but we do not have the value of theta. In order to get the value of theta, we use the formula S equals to radius times theta. Rearranging the formula, theta is equals to divided by r. S is equals to 3.5 divided by 1.5. We get the value 2 and 1/3 radians. Substituting the value that was obtained to the above mentioned formula, 1/2 multiplied by 1.5 inches squared multiplied by 2 and 1/3 minus sine 2 and 1/3 radians multiplied by 180 degrees over pi. This is needed because you cannot compute the value with only radians. You need it to be first converted to degrees. Therefore, the area obtained is 1.8115 inches squared. In problem number 6, the question is, the length of one side of a rhombus is 12.21 cm. One of the interior angles measures 60 degrees. Find the length of the longer diagonal of the rhombus. In order to visualize the problem, this figure is represented. So one side of the interior angle of the rhombus is 16. Therefore, the opposite side is also 60 degrees. And in this case, since the total sum of the angles is 360, 360 minus 60 times 2, that is 120, equals to 240. And 240, since there are two sides, you divide it by 2. And that is, the value that you get is the angle that is indicated, 120. So with the use of the cosine law, since it can be observed in the figure that a triangle is formed, c squared equals to a squared plus b squared minus 2ab cosine of c, wherein a and b is 12.21 cm, and cosine of c is cosine of 120. C is 21.1483 cm. So the length of the longer diagonal of the rhombus is 21.1483 cm. Question number 7. A mouse fell on a bucket of water wheel with a diameter of 379 cm, which traveled an angle of 190 degrees before it dropped from the bucket. Calculate the linear cm that the mouse was carried by the bucket before it fell. So we will first identify what is indicated by the problem. So at first, the mouse is dropped in a bucket, as seen in the figure, and then the water wheel moved 190 degrees. As you can see in the figure, the water moved. In this case, we would need to obtain the problem wants us to find the S, wherein S is equals to radius multiplied by theta. In this case, the diameter is already given by 379. We divide it by 2, wherein this would get us the radius multiplied by 190 times pi over 180. Since the value that we will get here at first, we need that the theta would be in radians. Therefore, S is equals to 628.4058 centimeters. For the last question, number 8, the length of the sides of a triangle is circumscribed in a circle is 10 cm, 15 cm, and 24 cm. Find the radius of the circle. And in this case, we must recall that the area of a triangle is equals to A multiplied by B multiplied by C over 4R. And rearranging the formula, we get R is equals to A times B times C over 4AT. With the use of the Heron's formula, since we already given the sides 10 cm, 15 cm, and 24 cm, we obtain S that is 24.5. And substituting the values in the Heron's formula, the square root of 24.5 multiplied by 24.5 minus 10 multiplied by 24.5 minus 15 multiplied by 24.5 minus 24, we get the area of a triangle is 41.0784. And in this case, since we already have the area of a triangle, we just need to substitute from the above formula that R is equals to A times B times C over 4 area of the triangle. We get a radius of the circle that is 21.9093 cm. Thank you. That is all.